Hey YouTube, what's going on here? Alright, we on the revision, and right now we've just finalizing this topic about angles, line, and polygons. So we've done a lot. That was the pretty good practice. Hope you enjoyed with that. Hope you also could do all those problems that I listed here. That was actually, so 20 was pretty complicated, so 21 that we considered in the previous video was also interesting because it took several actions, several operations, several equations. So that's also kind of high level, so we'll go to the next one. Alright, so 22, calculate the size of angles A, B, C, D. So not drawn accurately. So pause the video, try to do by your own, and we start explaining here. Alright, so what we know, we have two parallel lines. So basically, that's two arrows means that two segments are in parallel. Okay, so because they are parallel, what we can do, we can use any line. For example, if we use that line, so we consider that corresponds to the side of the biggest triangle. So it simply means that this is the second line, right? Second line. And if it's so what we can conclude? We can conclude the following. The angle C with that angle should form 180 degrees. But this angle D also the same with that angle, because we have two parallel lines and we have two angles that correspond to each other. All right, so what we can do, we can say that angle D is also here. So in order to connect maybe D and C, we can put inequality because D and C will form 180 degrees. All right, so let's refer back to angle A. That's the first equation that was set up. We also know that A and 70 together will form 180, so that's why we can immediately calculate angle A. So A plus 70 is also form 180, from where A is simply 110 degrees. Okay, so we know angle A is 110 degrees. What we also can do, we can try to figure out the rest angle here. Because we can see the triangle, let's put letters A, B, and C. So we have triangle, statement number 3. We have triangle ABC, and we know that 70 with 60 with some unknown angle, let's put some letter X for a while, will form 180 degrees. So that's why, from where we can find the value for X. So X is simply 70 and 60 is 130, and we subtract for it from 180, we'll get 50 degrees. Okay, so we know instead of X, actually we have angle, which is, okay, I put that X, which is 50. Okay, statement number 4, what we know about D and X. So D, an angle X that we calculated previously, will form again 180 degrees. So we're definitely sure that D is 180 minus X, or we'll put 50 degrees. That means it's 130, all right? So we've got angle D, so D is 130. And let's go back to the previous statement. Not the previous, but the very first one. So we know that angle D is 130. Now we can easily calculate angle C. So angle C is 180 minus 130, which is simply minus 130. Okay, I just correct that quick. 130, which is 50 degrees. So looks like angle C is the same as angle X, and this is obviously. Actually, we can skip that and just simply refer to two angles which are the same. So angle X is actually angle C. All right, that's how we can work out all the angles measures. All right, so problem 23 here. Calculate the size of angles X, Y, and Z. Okay, so what we have, we have angle X with angle 95. They will form together 180 degrees, an open angle, from where X is simply 180 minus 95. So it's simply 90 minus 5, you'll have 85 degrees. So we know now this is 85 degrees. All right, so next one. Can we figure out angle Z? Yeah, we can. Let's mark 3 letters for the vertices A, B, and C. So let's consider triangle A, B, and C. So if you add all the angles, 95 plus 15 and plus unknown Z, will get 180 degrees. The sum of all interior angles, from where Z is simply 95 and 15, will get simply 90 plus 20 is 110, and then we subtract 180 minus 110, which leaves us with 70 degrees. So angle Z is simply 70 degrees. Okay, we found that. So in the last one, Y. We know two sides, AC, and let's say this is D, AC side equal to DC side, because triangle is equilateral, and because of that, this angle is also X or 85, as we found. Okay, we have two angles, 85, so that's why in addition with angle Y and 2 times 85, they will arrange 180 again. So from where angle Y is simply 2 times 85 is 170, so angle Y is 10 degrees. All right, so 10 degrees stays for that. All right, so we've done that, 23. Let's go to 24. This is quadrilateral with 4 angles in degrees. Okay, all measures in degrees, of course. So naturally, you can think about like radians, but this is not the case because 90 radians is quite a big amount, right? So all angles should be in degrees, of course. So first you need to show that 5x equals 240. Okay, because you have an equation, so where it should come from? It should come from the sum of all interior angles, as you've seen in previous videos or in previous problems. So that's why we just simply need to add all 4 angles. So x plus 20 plus x plus 90, then x plus 10, and finally plus 2x. And it will form, not 180 but 360, because it's quadrilateral. And of course you can use the formula, general formula for polygon, for the sum of the angles, to infer this amount. Okay, but I remember, and I hope you do the same. So x plus 20, let's simplify that. So we have in total 5 x's, and in degrees we have the following numbers: 20, 19, 10. All right, so how much is that? It's 120. So that's why 360 minus 120 will give us 240 degrees equals to 5x. So work out the size of the smallest angle of the quadrilateral. All right, to answer question B, so first of all, anyway, we need to figure out angle x itself, like what stays for x. It's not the angle, but this is the variable. Okay, let's do 240 over 5. It's simply 48 degrees. All right, what's the smallest one? We just simply can calculate everything. So, but if you multiply by 2, you'll get 2 by 48, which is 96. This is 96. This is pretty small because x plus 90, you'll have more than 96. So you just simply erase that. This doesn't work. Okay, next one, x plus 10. That's good value. It's smaller than 96. So that's why you'll get 58 here. And now we can't exclude 96 at all. And obviously x plus 20 should be more, so we exclude that. and we're left with the smallest angle, which is x plus 10. So that's why 58 is the smallest angle for that. And this is his right-hand side. Okay, so we've done 24. Let's go to 25. So the figure shows a rectangle that touches an equilateral. So rectangle and it touches equilateral triangle. Find unknown angles. Okay, so what we can do, first of all, let's mark all sides the same. I hope you do the same. So because all sides the same, we know that degree measures for each angle, interior angle, is 60. So actually we need only that one, right? So let's consider this is angle X is on the top. So what we can say, this angle is 90 degrees because it's a rectangle, right? And we can calculate the rest part. Let's put a y value. So we know now x plus 90 degrees and plus y value will form 180 degrees angle. Okay, just have the line. This is the line, and all angles centered at this point will arrange 180 degrees. Okay, now if we find y, we'll be able to find x as well. So now let's have a look at this triangle. So I highlight with the yellow one, just shade with yellow color. Okay, let's have a look at this triangle. So from this yellow triangle, we can figure out that y angle plus 30 degrees angle and plus the rest angle, which is obviously 180 minus 60, right? Which is simply 120 degrees, will form again 180 degrees in total. So from where y is simply 30 and 120 is 150, so we just simply subtract and we'll get 30 degrees here. So y is 30, and then we can figure out just simply by plugging y the degree measures that we recently found. So x is simply 180 minus 90 and minus 30. So it looks like angle x is simply 90 and 30. We'll get 90 minus 30 is 60 degrees. Okay, so we calculated the angle x is 60 degrees. Alright, so let's move next. So 26, oh, it's in a circle, interesting. Okay, so here is an equilateral triangle with a side of 2 centimeters. Because it's equilateral, obviously, you have all sides the same. So that's why I mark all the sides the same. So in other words, all sides like PQ equals QR equals PR, and that stays for each one 2 centimeters. So find AB. So AB is a perpendicular. Okay, so how to work it out? So I think that it's good if you also consider triangle ABR, the smallest one. I just mark with that yellow shading. Okay, so ABR triangle, it's a right angle, right? Right angles. So what we can figure out, we need to find AB. So what we know the angle, and probably we know that QA by theorem, it's a bisector that bisects in the point APR. So basically we can say that PA is equal to AR, and each one by 1 centimeters. Okay, so that's why finally we have a triangle which is right angle, and it also has the side, the longest side, which is hypotenuse AR, which is 1. So we prove that. So by the way, because it's equilateral, the angle R is simply 60 degrees. So that's why we know that if it's 60 and this obviously is 30 degrees, what do we know that? So there are 2 ways you can use trigonometry. If you remember SOHCAHTOA rule, yeah. Okay, I don't write because I never used that SOHCAHTOA rule, but if you learn to do that, you simply can't do. But in this case, because it's 30 degrees and 60, how to figure out AB? So we need to figure out AB. This is unknown. So x simply from here is, it should be, if we use SOHCAHTOA rule, it's hypotenuse times, for example, we take angle 30, we simply use 1 times cosine 30. That's using trigonometry. And you'll get cos 30 is square root of 3/2. Okay? But you can also have a sine of 60 in this case. So that also works. So in this case, it's square root of 3/2. Or you just can remember the properties. If hypotenuse here and you have angle 30 degrees, you can easily find side BR because it's opposed to 30 degrees angle. That's the alternative way. So alternative way is to use 30 degrees rule in right angle triangle. So what we can do, we can figure out that BR simply should be half of their hypotenuse. So it should be 1/2 because it's opposed to 30 degrees. All right, I hope you know this rule. If you don't know, just remember trigonometry. That's also very helpful here. So 1/2. So that's why if we have triangles with sides 1/2, how to find x? So use Pythagoras. Okay, Pythagoras theorem. So using Pythagoras, we know that 1 is the hypotenuse. 1 squared is always 1/2 squared and plus another side, another leg, which is x squared. From where you can easily find x. So transfer 1/2 to left side and square it up. You'll get 1 minus 1/4. So which is also 3/4. And now we take the square root. So it's going to be square root of 3/4. But square root of the fraction, square root of both parts, so we get square root of 3/2. Or, so, and we arrive to the same answer. Or you can simply use, calculator and just calculate. So use calc and calculate. I can do it just manually. All right, so we've got 26 tasks. Let's see, do we have anything? No. Okay, so that's the end, guys. Hope you enjoyed. That was powerful revision. Actually, lots of tasks. So 26 tasks for one topic. It's pretty good. So actually, I think it will be good. And you also share your opinion whether it's better to create several videos to split, in smaller parts so that you can watch in full. And you can practice, let's say by 5 or even by 7 tasks and problems from GCSE exams and similar problems. Okay, and sharing your opinion in the comments to that video. So I'll take into account, and because you guys, those videos is for you. So you decide in which format is appropriate for you. So right now, I'm not sure about the format because right now I have very low subscribers. So mostly several students and other guys who are interested in this video. So don't hesitate and just share your opinion about which format is the best for you. Because you understand that it splits theoretical basis and sort of practice in 2 different ways. And so you guys tell me what to do next. Hope you enjoy. Don't forget to subscribe and don't forget to press the bell button to have the latest updates. That was Daniel Dallas with you guys, and goodbye.